Let's graph a parabola in the form of y equals x squared plus k. We're going to graph three parabolas and compare them. The first will be y equals x squared, the second will be y equals x squared plus 2, and the third will be y equals x squared plus 4. To graph this parabola, we're going to replace the x value with these five key values. So when we do the first step, what we're going to do is replace the x with -2. So -2 all squared is 4, -1 all squared is 1, 0 squared is 0, 1 squared is 1, and 2 squared is 4. So now that you have your xy coordinates, you have -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. You're ready to graph the first parabola. So let's graph the vertex first. We start at the origin, 0, 0, and now we plot the two symmetrical points, 1, 1, and -1, 1. Now we're going to plot the second pair of symmetrical points. It's at 2, 4, and -2, 4. And now you can draw a nice curve between all five of these key critical points, like so. Now let's draw up a table for y equals x squared plus 2. What you can do as a shortcut is you have 4, 1, 0, 1, and 4. These were the y output values for x squared. So what you can do is when you see this x squared, you know that the y output values are going to be this. So copy this column and place it here as follows, and then add 2 to each of these components. So visually, let's explain like this. Transcribe 4 here and then add 2 and you get 6. Take the 1, add it here, and add it to 2 and you get 3. Take 0, put it here, and add 2 and you get 2. Take 1, add 2 and get 3. Take 4, add 2 and get 6. So again, just to reiterate, take this first column, which you have here, and just add 2 to each of these values as such. And you'll see that 6, 3, 2, 3, and 6 are going to be your y output values. So let's graph the 5 key critical points, starting with the vertex. The vertex is 0, 2, and let's plot our first pair of symmetrical points. You have them at 1, 3 and -1, 3. Now let's plot our second pair of symmetrical points. We have 2, 6 and -2, 6. So now draw a curve through these 5 key critical points. And your graph should look like this. Now for the third and final graph, we have y equals x squared plus 4. And again, what should you do? Just take this table column, like so, and transcribe it here. And then what you're going to do is add 4 to each of these values. So 4 plus 4 becomes 8. 1 plus 4 becomes 5. 0 plus 4 becomes 4. 1 plus 4 becomes 5. 4 plus 4 becomes 8. And so now you have the xy coordinates for y equals x squared plus 4. Let's graph it. Starting with the vertex, you have 0, 4. Now plot your first pair of symmetrical points. You have 1, 5 and -1, 5. Now plot your second pair of symmetrical points. And you have 2, 8 and -2, 8. Now draw a curve through these 5 key critical points. And there you have 3 parabolas, like so. So what did the k value do in terms of the first parent function y equals x squared? What happened? Well, what we should note is that the variable k here affects the parabola by causing a vertical shift of k units up. To help you visualize this a little bit better, recall that y equals x squared was the purple graph. And when you add 2 units to it, you simply take this function and translate it up 2 units so that the purple function becomes the red function on the graph. If you want to understand the relationship between the purple function and the green function, recall that what you did was y equals x squared plus 4. You just took the original parent function y equals x squared and added 4 to all of the y units. So the purple function translates 4 units up to become the green function.